Good morning, afternoon, or evening, statisticians. Looks like I'm in a closet, but this is the only quiet place in the high school right now. Today, we are going to be wrapping up our Unit 2 exploration on z-scores and the normal distribution, learning about some calculator functions so that we can find the proportion of values in a specified interval and the value that corresponds to a given percentile in the normal distribution, so we can determine whether a distribution of data is approximately normal from graphical and numerical evidence. If you have not at this point downloaded our two different calculators onto your device, I would encourage you to do so. You can see what the apps were called back in lesson 1.4. To start today's lesson, I'd like to get a quick pulse on your own self-efficacy. So drag this red dot and let me know where you stand on a scale of 1 to 10. And then if you could provide me with some insight, that would be awesome. All right, so we're going to continue to focus on this idea of IQ. There is a society known as Mensa. To obtain admission to this high IQ society, you must score a certain value on an IQ test, and that would deem you admittance to the, all-knowing society. So today's key analysis is, can we identify who's smart with data? We're going to review a little bit of what we had done last class before delving into some new information. So we're going to start here once more with the distribution of IQ scores is thought to be normally distributed with a mean of 100 and a standard deviation of 15. So right then and there, I'm going to begin the process that we outlined before. If you have forgotten it, we are going to review that process very briefly. So the first thing that we want to do is draw and label the curve. What does this entail? That includes the mean, standard deviation, ticks, and then shading the area in question. All right, so let's continue to label our standard deviations here. This is going to be a value of 115, value of 130, the value of 145. If you're wondering how I'm getting those, I'm simply adding the standard deviation to the mean that was provided to us. 100 plus 15 is a value of 115, so on and so forth. And then obviously contrastingly subtracting 15 from 100 to get the range of scores that would pertain to each standard deviation from the mean. Now, assuming that this is true, you take an IQ test and get a score of 130. What percentile am I at? So a score of 130 is going to place me here. And if I had a better sketch tool, I'm going to do, oops, I don't want to do that. In here. That's awkward. All right, back to what I was saying. So we're going to shade here along the bottom. All right, I got a little bit more of a thicker crayon for today. So I want to know, what is the percentage of this space that I'm shading? So we talked about last class that in a normal distribution, 50% of the data is above the mean, so above 100, and 50% is below. So we know that at least to the left-hand side of 100, we have a value of 50%. But using the empirical rule, one does the overlaps too. That's pretty cool. Right? So utilizing the empirical rule, we know that a score of 130 is 2 standard deviations from the mean, which encompasses approximately 95% of the data, since we only require the percent of data between the mean and 2 standard deviations. We can divide 95 by 2 and get a value of 47.5. Thus, we can say that score of 130 will place you in the 97.5 percentile. So back to our normal curve procedure, as I have just done in step 2, we're going to perform calculations and show our work. And then number 3, we are always going to answer the question in context. That is key. We don't want to just leave numbers there and allow the reader to blindly interpret. Now, what if we were tasked with determining the percentile for someone who scored at a value of 124? What makes this a little bit more complex or unfamiliar as compared to our previous question of 130? I would like for you to establish some dialogue with your peers before moving on in the video to what comes next. So as you can see here, we need to use a calculator. There are 2 different functions within the calculator that we can utilize to help us determine percentile ranks. So finding values from percentages or finding percentages from values. So the way we're going to do it is in the upper left-hand corner, we have the second button, and then next to the left and down arrow key, there's a VARs button. When you click that, you'll have 2 different, or a menu of options appear. You'll want to select either 2 or 3. So as you can see here, I have a little image that you can kind of follow, and you are going to first use the NormalCDF. So the NormalCDF means that you've been given the particular data value, and you are looking for the percentage. So using our handy dandy calculators, and I'm going to try and show it through the video. Second, oh no, is my calculator laggy? Let's find out. Second, there we go, VARs. So here we are, second VARs. Oops. And I'm going to hit NormalCDF, so value of 2. As you can see, I have a lower bound and an upper bound. So my lower bound here, I just want to set it to something extremely low, extremely small. So let's take negative 100,000, comma. The upper bound is a value of 124. Now, notice I have currently a syntax error, and the reason being is because, as you can see here on our screen, I need to provide the calculator with these descriptive statistics, the mean and the standard deviation. So I know that the mean is a value of 100 and the standard deviation is a value of 15, and I get this decimal equivalent, 0.945. So if I interpret that as a percentile, that would be the 94.5 percentile. And if I check my answer, yes, receiving an IQ score of 124 puts you at the 94.5th percentile of IQ scores. So once again, remember, if we are provided with the data value and we're looking for the percentage of data, we are going to use the NormalCDF function. Now, on the opposite end of the spectrum, here we are given the percentage, and we are asked with, or tasked with, determining what score we would have to earn on the IQ test. I'd like for you to actually represent this proportion after you use the other function, which isn't showing up now, the inverse norm. So that would be number 3 here in our picture. I'm going to give you some time to work that out on your own, so I'd press pause at this point in time before checking your answer. So there are a few key points that we want to keep into consideration when solving questions pertaining to the normal curves. We want to draw and label the normal curve, calculate and answer. Percentile is the percent below a data value, At least means the data value and above. Inverse norm's input of area is always the area below the data value. To approximate an upper bound of infinity, use a very large positive number. And to approximate a lower bound of negative infinity, use a high magnitude negative number. So here is, since we are at the end of the unit, an opportunity for you to kind of go toe-to-toe with the concepts that we've been talking about. So we haven't changed any of the descriptive statistics here. And as you can see, Mensa International is an organization that accepts individuals who score in the top 2% or 2 sigma or more above the average on IQ tests. For an IQ test with a mean of 100 and a standard deviation of 15, what score would you have to get to qualify for Mensa International? Round your answer to the nearest tenth. I'm not really sure why I have the question again here, but should you use the NormalCDF or inverse norm for this problem? And then determine what that IQ score actually is. Now, after you determine that percentage, oops, maybe I gave it away just now, calculate how many geniuses are living in the United States if there are 328 million people. Geniuses according to the Mensa International definition. And that is where we're going to pause this video and pick up altogether in class.